Okay guys, so welcome to my algebra playlist. This is my first video. Today we're going to look at how to factorize monic and non-monic quadratics. So before we start, we're going to look at what monic and non-monic quadratics are. Monic quadratics are simply quadratics where the coefficient of the x squared term is 1, and non-monic quadratics is where the coefficient of the x squared term is anything other than 1. Okay? And when we talk about a quadratic, we mean a quadratic written in this form. So this here is the x squared term, but what we're primarily focusing on is that coefficient of the x squared, so that a. Alright, and if that a is 1, it's monic. If that a is not 1, then we get non-monic. Okay, now let's look at a few examples as to how we can factorize these. So the first one here, I first want you to have a go at identifying which one is monic and which one's non-monic, or if they're both monic or both non-monic. So in this first example, we can see our coefficient of the x squared is a 1, because if there's nothing there, we assume there's a 1 there. So therefore this one is monic. And the way we go about solving monic quadratics is we need two numbers that add to give something and that multiply to give something, all right? And we need to work out what these two numbers are, all right? The numbers that they need to add to give is simply your b value, right? Which is the b value up here. It's the coefficient of the x, all right? So the x term, and then you look at that coefficient, and that's a 5 there. So we need two numbers that add to give 5 and that multiply to give you a constant term, which is 6. So you can either use the inspection method or think of your factors, but of course those two numbers are 2 and 3, right? And we can check that. 2 plus 3 equals 5, and then 2 times 3 equals 6. So both of these are satisfied. Now we can, what we do with our two numbers is we can simply split up this middle term, and we end up with x squared plus 2x plus 3x plus 6 equals 0. I haven't changed the expression. All I've done is split up that middle term. Now we can factor out an x. We factorize in pairs. We get x outside of x plus 2 plus 3 outside of x plus 2 is equal to 0. We take what's common in both, which is an x plus 2, and then what we're left with is x plus 3. So that is fully factorized, and therefore our solutions are x equals -2, x equals -3. Now if we look at a non-monic example, we need two numbers that add to give -8 and that multiply to give. The difference here is that the number that goes here is simply the product of this and this. So 2 times 8 equals 16. So we need two numbers that multiply to give, not 8, but 16 this time. Okay? So the only difference is this number here is simply the product of your A and C, okay? All right, so of course those two numbers via inspection are -4 and -4, because -4 equals -8, and -4 times -4 equals +16. So we're going to use the same splitting method where we split up the 8x, or the -8x, sorry, into two terms. And now we can factorize in pairs. So take out what's common. I'll do another video on factorizing in case this doesn't make sense to you. But simply, so we'll get 2x outside of that. And then here we'll get a -2x. Oh, sorry, not x. Just a -2 outside of x minus 2. Oh, sorry, this should be a 4. My bad. Okay, and we can check if we're right via expansion as well. But again, we take what's common in both terms, which is an x minus 2, and then what we're left with is 2x minus 4. And this is equal to 0. If we let each factor equal to 0, we get x equals 2, or x is equal to +4 over 2, which is 2. So we get the same answer. And that is how you factorize and then solve quadratics, both monic and non-monic. Thank you.